hi everyone, thanks for joining into my talk. My name is Meirav, and today I will share with you ways I found in which NetworkX can be useful to us when we do clustering analysis. But before that, quick hello. Hi, I'm Meirav. I'm a data scientist at Salesforce. I'm from Israel. I live in Tel Aviv. I have a master's degree in bioinformatics, where my research focused on the microbiome. And I also did side projects in virology, immunology, and epidemiology, but it was before the COVID, so nothing really interesting there. Sometimes I write blog posts. You can find them on Medium, and I will also show a link to the blog after. And fun fact, I do photography, and I also contribute to Shutterstock and Getty. So if you're curious, you can Google my name and find the images I took over there. And that's all about me. So the agenda for today is as follows. First of all, we'll do a small graphs recap. So as promised in the talk description, there is no prior knowledge needed. Even if you don't know what a graph is, we will have you covered, but really briefly. Then we will do a short intro to NetworkX, which is a really good package for analyzing graphs. And then I will show some examples of how NetworkX can assist us in clustering analysis, as promised. Good, so from the very beginning, a graph is a collection of nodes, which are basically dots in space, and edges, which are lines connecting them. And what is powerful about these data structures is that it allows us to represent both entities and the relations between them. So just a few common examples of things being represented with graphs. We have the most familiar example probably is social networks. We have event graphs where you can represent, for example, airports like flights, airport, flew from, arrived at, etc. We have networks of neurons. And we also have citation networks where every paper is a node. And if a paper cited another paper, then we will draw an edge to it. And in that context, I wanted to show you a really useful tool. I just thought of it this morning, that's why it's not in the slides. So this is called connected papers. Does anyone know it? You do, cool. If you don't, even cooler. So you can put a paper here and then build a graph. And then you get like the landscape of the paper you looked for, and it's really useful for doing literature review. So pretty quickly you get the preview of the paper, like the abstract, and you can see how central it is in the landscape of where it is. And you can see some that are peripheral, like this one only cited another paper and hasn't been cited once, etc. So it's really useful. I highly recommend using it, and it's an Israeli development, so I can be proud of where I'm from. Good. And in the context of clustering, we can use graphs to represent, for example, entities belonging to a cluster or distances between clusters to see the landscape of our data pretty easily. So those are just a few examples. Now, two more things that make graphs really hot is first that it's been around for a long time. The first time a paper has been published in the field of graph theory was in 1735, which is pretty much handing to us on a plate 300 years of research in a really hot field. And we have tons of algorithms we can apply right away on our data today to get answers to really hot questions. So, for example, we can use for transportation shortest path, for Yango, Uber, etc. And the second thing, which I wrote one for just to test your concentration, it keeps advancing. So nowadays we have ML algorithms specific for graphs, for example, link prediction, which allows us, given a set of nodes and edges that are already connected, to predict which edges will be connected in the future. So if anyone is still on Facebook, am I the only boomer still on Facebook? Good. So you know the feature of people you may know. So one way to calculate that is link prediction. And another thing that exists today is graph neural networks. So you can study graphs in deep learning manner using, for example, a PyGeometric, which is a platform built upon PyTorch, and you can do deep learning on graphs as well. So now that everyone in the room convinced that graphs are the thing and we should be using those, the next question we should probably address is how. And my answer to that is NetworkX, which is my go-to library when I want to work with graphs. So according to their documentation, it is one of the most frequently used Python packages to create, manipulate, and mine graphs. And what does it provide? So first thing it does is it provides us several classes to store different types of graphs, for example, directed, undirected, all types. It covers a lot. It gives us a really simple conversion of data from pandas data frame to a graph, which I find super useful. It has a really big set of visualization methods with lots of features, like you can do several layouts of the graph, you can color edges, you can color nodes, you can do sort of a heat map where your edge color is darker the higher it is and brighter the lower it is, and many options. And you can find examples in the gallery section. And also it gives us plenty of useful methods to study graphs. For example, from basic characteristics of a node, for example, the degree and the between centrality, like how central it is, to advanced algorithm implemented, for example, community detection, page ranks, and many more. So I really recommend looking into that. And another really good feature I like about NetworkX is the gallery section, where you can find lots of code and notebooks with examples of advanced things you can do, such as really complex and detailed visualizations, as well as how to apply advanced algorithms on data sets. But how is this all relevant to clustering, you must be wondering, so I will tell you right away. So first thing we can do with the NetworkX that is useful for clustering is visualization. So on my master's degree, I had a problem. I did lots of clustering on bacterial data sets, and I always had a problem with displaying my results, like aesthetically and in a way that conveys the idea. And I couldn't find a solution to it back then. And then after I graduated, I did a side project where I took data set from the UN about female representation in parliaments worldwide. And I had a table with subcontinents, and by subcontinents, you can see the results here. It means Eastern Europe, Central Asia, Central America, South America, etc. So I had a bunch of those, and I had per each one, per each year since the 90s until 2019, how many seats were taken by women in their parliaments. So I had a table where each column was a year, each row was a subcontinent, and each cell was how many representation, and then I had all those patterns per subcontinent. So I decided to cluster those and see if I have groups of patterns I can learn from, and like which subcontinents behave the same. So I clustered those into 5 groups, and again I had the problem of how to represent it. So after digging really deep in the results in Google Images of clustering results visualization, I stumbled upon this visualization done using a package I never heard of before called NetworkX, and I really liked it. And that's how I learned about this package and its visualization options. So what I did was I represented my data in a data frame where I had 2 columns. One was subcontinent, and one was the cluster. And I converted this into a graph where I got 5 components that were connected, and the cluster number was in the center. And that's how I managed to visualize my groups of results. And it did the layout and all the nice, circles around and the placing in the space for me. So I really recommend looking into the visualization. And I do want to highlight that it doesn't even have to be done using graphs. You can just convert your data to graph for the visualization and then get back to what you're doing. So I found it really, really useful, and I hope that so will you. Now, the second way is that, let's say I have a data set of sentences, and that it's really big, like 10,000 sentences. And I want to get an idea of what people are talking about in this data set. So I'm running k-means, and I'm not exactly sure how many clusters I should be clustering to. But I don't want to divide too roughly. Like, I prefer to have many groups that are very specific instead of one group that contains lots of, things that are fairly related. So I cluster my data set into 40 clusters, and then I start looking into the results. So I look at the first cluster, and I see the sentences. I figure that this is of certain topic. And then I look at the second cluster, and I figure it's of another topic. And then after a few clusters, I start seeing that some topics come up several times. Now, there is some logic in the way they were separated into groups, but they all belong to one higher topic. And now I want some tool to automate the process of grouping together all those clusters that had the same higher topic. So one way to solve this would be hierarchical clustering, but I already have the results of k-means, and I'm pretty happy with them. I just need a tool to automate it for me. So what I suggest doing is as follows. I will convert my data into a graph where each node is a center of a cluster, and each edge is the distance between a pair of clusters. Okay? Good. So as you can see on the left side, I have a graph that is fully connected because each pair of centers has a distance, obviously. And then I say, actually, I'm only interested in ones that are really close to each other because that's how my space will look, right? If I'm looking for places with the same topic. So I clear out all the edges that are above some threshold. And that's how I get the second part of the graph. And in this graph, you can see that I have, again, independent components. And I define those as the groups with connected topics. And then I can easily extract the list of clusters using NetworkX. And I will show an example of the code used for this. Good. So let's say I already trained a k-means model, and I named it in a very original name. I named it k-means model. So first thing I do, I extract the centers using k-means built-in function called cluster centers. Then I calculate the distance between each pair using scipy's pdist function, which receives an array, and the method you like to calculate the distance with. I chose cosine, but it's not very important. Could be Euclidean as well. Then I turn it into a square form. And this is important because later on I will want to turn this into a data frame. I can convert the graph. So what it does, it basically turns it into a matrix with the distances between each pair. And the size of the matrix is k on k. Cool. Now I turn this thing into a data frame, or I have three columns, cluster 1, cluster 2, and the distance between them. Okay, and don't forget to reset the index always. Then I name the columns cluster 1, cluster 2, and dist. And then I start doing some pre-processing. That's all the part here. So the first thing I do is I remove all rows where the distance is 0, because these rows include cluster distances from themselves, and with all due respect, it's not interesting to me. The second thing I do is I remove all the rows where the distance is above some value. Now here I set it to be 0.1, but it's really arbitrary, and you can play with different values, and you can also do it automatically using, for example, a z-score or some percentile, right, to fetch the distance for you. But for me, it worked with the 0.1. And the last thing I do, I demand that in all rows, my cluster 1 number will be higher than cluster 2 number. Why is that? Because I don't want to have duplicated rows, right? Because each pair will appear twice, like in cluster 1, 1, 2, and then 2, 1, and I only want to have it once. So that's how I drop all the things that I don't care about. And then, as I promised before, this is how you convert data from pandas to graph. So what it receives is the data frame, the from, and the to. Even if it's undirected, that's what it expects to receive. And then what will happen is that the extraction will happen. So this function extracts all connected components in the form of a list. And this part of the list comprehension will iterate over each component and put all the nodes that belong to it in a list. And then eventually in S, we will have list of lists with the nodes belonging to each component. And I really invite you to try it out yourself. I found it really good, and although it was a little complicated and took a while to explain, it's really straightforward once you understand to have the code on a plate. So you're welcome. Good, so what we did today was a really quick graph recap, a small NetworkX tour. I showed you ways in which NetworkX and graphs in general can assist us in clustering analysis, and I will say that there are other packages as well you can explore and other visualization methods and stuff, so you don't have to stick with NetworkX. I was just finding it convenient to show the code which I use, and we had loads of fun, at least me. Any questions?
Thanks for the presentation. I have two questions. One is, when working with sentences to cluster, to grab them and then create clusters, how important is excluding stop words? So,
Sorry, I don't understand.
I mean, general terms which doesn't have anything. I mean, stop words.
Mm-hmm.
Is it important to exclude them? Because if you don't exclude, then you'll get a lot of artificial clusters, right? And the second one is where to stop when we choose the number of clusters. You mentioned you are doing some optimization probably, and what kind of indicators we use to say that this number of clusters is the best one?
So I usually use the elbow method, you know, when you cluster, you know, this method.
Mm-hmm.
So
And
around
NetworkX
here
has
should be.
this elbow indicator?
What?
NetworkX package.
No, NetworkX is only for analyzing the results I already have.
Mm-hmm.
And everything else is done using, I don't know, sklearn. So in the scope of this talk, I only discuss ways to handle results I already received using clustering. But for choosing a number of clusters, I usually use elbow, and I sometimes just run like randomly and see if it makes sense, like roughly, like if 40 didn't satisfy, then 60, like this kind of thing. And regarding what you said about stop words, it depends on the embedding method you're using. So if you're using TF-IDF, etc., that refers to the word itself, then it will probably yield really noisy results if you don't do the cleaning before. But if you use methods such as SBERT, which is BERT for sentences, then you don't need to do all the pre-processing. In fact, it's better to not do it because it understands the context of the words, and it gives the embedding according to the word in relation to the entire sentence. So I hope it answers.
Okay, thanks. And one more question about networking, about graphs. The NetworkX package has some tools to do graphs on n graph. Like the traditional packages, they use bgram to create plots. So you can create a unigram plot or bgram plot.
I think it allows you to use all types of graphs you like.
I mean, can we create 3 gram or 4 grams pod?
I think you can. I mean, if you have a sentence, this is me, then you can convert it to words adjacent to each other, like word 1, word 2. This is, and then is me, and then ask it to do a graph for you. Then I hope you can see something and also understand the handwrite. Then this will be connected. And if you want this to be connected as well, although it's not adjacent, then you should write a function that iterates like this. Right? And then you will have this, me, and you will have the trigram as a connected component. Is this what you meant?
Yes. So we don't have built-in like 3 gram. So basically what you drawn there, it's bgram, right? So you use bgram all the time. This is me, is or
I don't think they have a built-in package for a function for conversion. You would have to implement it yourself. But if I understand correctly what you mean, that you should be breaking down the sentence according to your requirements, like as I did here, maybe without fully understanding what you intended, but I tried. And then you convert this from the data frame. Sorry. So you have a sentence. You convert it to data frame, and then you convert it to graph on your own. And then you can do the entire analysis, visualization, all the fun things I showed you with NetworkX. But NetworkX will only work for converting from data frame and also other data types. So if you dig into the conversion functions, you might find something relevant to it. And I will also say that this is open source package. So if you think it can be useful to implement methods for NLP as part of the package, then you can do it. And they will be really appreciated. Okay.
thanks.
Thank you very much for a very interesting speech. I wanted to ask if you have tried some other packages other than NetworkX, for example, iGraph. They said that it could be faster in some ways, so I wanted to know about it.
Which one now? How did you go?
iGraph.
I noted to myself, and I will come back next year with the comparison.
Oh.
No, I'm loyal to NetworkX.
Yeah, yes.
Anyone else want to ask? Cool. Glad to hear. So thanks a lot for your time. This is the link to my blog post. Please visit. I didn't publish in a while, but I hope to publish again soon. And I would really appreciate to hear your comments. You can hear about the work on women in parliaments. This is my LinkedIn. Please feel free to connect. I will be happy to approve and have friends in Armenia. And also, this is my mail. Feel free to reach out if you want to ask any question, like, how are you, Meirav, nowadays? Great. So thanks a lot.